Hey guys, happy Tuesday, happy Tuesday. So yeah, obviously I'm still not there today, so just make sure that you guys follow along with today's video. Couple things. Remember, if you did get a notebook, I would appreciate it if you guys started taking notes in that notebook, right? Because we are going to reference those a lot this semester. We're going to go back and review. So again, if you have that notebook, please make sure you're taking notes today. Following along with this video, make sure all of that gets copied onto that notebook, right? So the warm up, then your notes. Make sure that when you get to that class activity, make sure it's on a separate piece of paper because you will be turning that in, and I do not want you guys to turn in your notes. Eventually, I will check your guys' notes, um, but I don't want you guys to turn in your notes alongside your class activity. Now, if you still do not have um, a notebook, that's okay. That's okay. Just make sure you guys get one as soon as possible because I did provide you guys with the Go Formative where you guys can take notes the good old-fashioned way like we were doing last semester. But like I said, starting next week, there won't be any more Go Formatives. We'll go back to just taking notes inside of our notebooks. All right. So let's go ahead and get started, guys. What I would appreciate if you guys can do for me is just go ahead, pause the video right here, try this warm up, and then when you're ready to see the solution, go ahead and hit play. All right, so assuming we went through this, let's see what I would do here first. I see that I'm solving a multi-step equation, so I see I have parentheses. I should attack those first, and I'm going to get rid of them by distributing. I multiply the number in front. 5 times negative 2x. Well, that is going to be 5 times negative 2 is negative 10. That is negative 10x. What is 5 times positive 2? Well, that's going to give me a positive 10. Everything over here on the left, the 70 and the positive 3x, just come down, nothing special with that. All right, at this point, I see that I do have like terms. I have a negative 10x and I have a positive 3x on the other side. So I do want to put those together. It's up to you which one you want to move over. Personally, I prefer moving the smaller one. It's just, usually you'll end up with positives instead of negatives. I prefer working with positives. So the smaller one here is actually the negative 10. It's actually a lot smaller than the positive 3. So the way we get rid of minus 10x is to add, we do the inverse. So we're going to go ahead and add 10x to both sides, plus 10x, plus 10x. So what happens here? 70 just comes right back down. We didn't do anything with that. 3x's plus the 10x's that we kicked over, that is now 13x. And that is equal to, those canceled out, we bring down our other 10 as well. Okay, we're down to a two-step equation. It's a little backward. It looks a little weird, but we can still do it. I have to get rid of this 70. I want to leave that x till the very end. So this is right now, this is a positive 70. The way you get rid of it, just like before, you do the inverse if you're going to do it to the other side. So we subtract 70 from both. 70 minus 70 goes away. You bring down 13x is equal to, what is 10 minus 70? That is going to give me 60. All right, so great. And that should actually be, erase that, I forgot my negative. 10 minus 70 gives me negative 60, excuse me. All right, we have one more thing that we have to do here, and that is to divide both sides by 13, right? We're multiplying 13 times x, so we do the inverse, which is to divide by 13. All right, so x is equal to negative 60 over 13. There we have it. All right, and again, we're going to leave it as a fraction. It does not divide nicely, so let's move on here. And today, guys, we are starting a new unit. This is going to be actually a pretty short unit. It's on properties of exponents. All right, so exponents, you should have seen those back in 8th grade. You probably remember something like 2 to the 3rd power. Remember seeing something like 5 to the 2nd power. Sometimes you'll see that as 5 squared. So we're going to be dealing with that a little bit, and then we're going to take it a step further to the Algebra 1 level. All right. So just a quick preview. These are the 5 properties. These are kind of, think of them as shortcuts. These are 5 properties of exponents, which are going to help us simplify. So you're not really solving anything. You're going to be having these problems, and you're going to try to make them smaller, compress them down by using these little shortcuts. One of them is called product of powers, power to a power, and those are the ones we're actually going to focus on today. These other ones, negative exponents, zero exponents, and quotient of powers, we'll save those a little later on this week. So again, today our main focus is product of powers and power of a power, and I'll explain what those mean here in a minute. So what do you recall? If I was in class, I would ask you guys this. Of course, I would hope I would get feedback here. So this first one, 2 to the 5th power, that is not 2 times 5. So please be careful. That is not gonna, you don't multiply those two numbers together. This 2 to the fifth power, what does that actually mean? It means you have 5 copies of the number 2 and they're all getting multiplied together. So what I mean is you have 2 times 2 times 2 times 2 times 2 5 times, right? And you're multiplying all those 2's out, right? So this is kind of what we call the expanded form, right? 2 to the fifth power. The expanded version of that is saying 2 times 2 times 2 times 2 times 2 5 times. And we can actually go ahead and actually simplify. We can actually multiply this. 2 times 2 is 4. If I bring down another 2, 4 times another 2 is 8. 8 times another 2, if I bring that down, that is 16. If I bring down that last 2, 16 times 2, that would give us a total of 32. 32. So again, 2 to the fifth power is equal to 32, but what I wanted you guys to kind of focus and get out of it is this part here, the expanded form. What does it actually mean to have something to some power, right? 2 to the fifth power. Very similar over here, kind of ran out of space since I started multiplying. But 3 to the fourth power, what does that mean? That means you have 3 times 3 times 3 times 3 4 times. And again, that is the expanded version of that. I could, since these are nice numbers, we could actually go through and multiply. And I'll go ahead and I'll do that. 3 times 3 is 9 times one more 3. That would give me 27 times one more 3 there. That would give me actually 27 times 3 is 81. 3 to the fourth power is 81, or it really means 3 times 3 times 3 times 3 4 times if we expanded it. All right, so this is what you should have covered back in like 8th grade or 7th or 8th grade. So how do we take it to the next step? Oh, a couple of other things actually. I didn't realize I had this slide. But a little bit of vocab before we get into these problems. So exponent, I've used the word exponent. So again, an exponent is a number or a variable. So it can be a number or variable. For us, guys, we're just going to focus with numbers. And it's in the upper right corner, also referred to as a power. So you'll see me use those two words going back and forth. I'll say something like 2 to the fourth power. The exponent is 2 to the exponent of 4. It's kind of awkward, but we normally say 2 to the fourth power. Power exponent is referring to the same thing. And again, it tells us how many times to multiply the base by itself. So what the heck is the base? Well, the base is the bottom number or the variable which we are multiplying. All right, so your base in this example here, if I can highlight it. So if you take a look at this example down here, I have a to the fourth power. Again, that's the exponent, sits up in the top right corner. So again, you kind of want to exaggerate it. So be careful. Like if I was to write this on the screen, I would write a to the fourth power. You do kind of want to exaggerate, make that exponent a little bit small, hovering up in the right corner. You don't want to do this. You don't want to do that. So be careful. Make sure your writing is nice and neat. So again, the base is that bottom number or variable. So here I have a to the fourth power. And again, what does that mean if I expanded it out? Well, a to the fourth power means we multiply a times a times a times a 4 times. Obviously, these are variables, right? A is a variable. I can't actually multiply that like 2 to the fifth power, right? So a times a times a times a is really another way to write it is a to the fourth power. All right, so again, and please be careful. We never multiply a base with an exponent. No, 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 no. That is a very common mistake. Please never multiply a base times an exponent. All right, so what I want you guys is to do with this one here, we're going to learn the very first shortcut. It's called product of powers. Why is it called a product? The reason it's called product is just a bougie, fancy way to say multiply. If you take a look at all these problems, we will be multiplying, we'll be multiplying, we'll be multiplying. So again, it's called product of powers because we are multiplying. We're taking the product, and yes, we are dealing with exponents. So that's why they say product of powers, not product of, well, I guess you could say product of exponents. All right, so what I want to see is if you guys can figure out the pattern. I'm going to work some of these out. And if you spot it, great, awesome, fantastic. But this is kind of the good old-fashioned way. This is how we learn those shortcuts. So look for the pattern. The first part here that I have, it says r to the second power times r to the third power. What I'm going to do here is I'm going to expand those. I'm going to expand this first one, r to the second, and I'm going to write it as r times r. Okay, great. And then I can multiply that, right? Multiply by r to the third. Well, if I expand r to the third, that means r times r times r. Well, why the heck would I want to expand it? Like that looks just like a giant mess. I want to simplify. I want to compress it. I want to make it. I hate using the word smaller, but I kind of want to reduce, make it smaller. I want to see what we call simplify. So how can I write r times r times r times r times r 5 times? Because that's annoying. Well, we're gonna write that as r to the 5th power. We're gonna go ahead and rewrite that as r to the 5th power. All right, so see if you guys can spot the pattern, right? Let's keep going with the next one here. A to the 4th power. What does that mean if I expanded it? I would write a times a times a times a 4 times. And then I would multiply that times one more a. And this is, you could, if you want to put a 1 there, we don't see it, but it's a to the 1st power. I would multiply it times one more a. So how could I rewrite all of this mess? Because that's just exhausting to write a times a times a times a 1, 2, 3, 4, 5 times. Well, I can rewrite a times a times a times a times a 5 times. I can rewrite that as a to the 5th power. I can put it back together and rewrite it and rewrite it. Okay, so hopefully maybe some of us are starting to see the pattern. And I'll highlight a couple things here. Well, I'll leave it to the end. Let's move on to the next one. Let's see. I have k to the 7th. So let me expand that. K times k times k times k times k times k. Let's see. There's 1, 2, 3, 4, 5, 6. Ooh, I missed one. 7. So we have 7 k's times, we're going to multiply it times something, and it should give me k to the 9th. So what should that be? Well, I already have 7 k's. If I multiply, 2 more k's into that, that's going to be k to the 2nd. Whoa, k to the 2nd power. K to the 7th times k to the 2nd is going to give us k to the 9th power, right? If I expanded all those k's out and I put those all back together, I would rewrite that as k to the 9th. All right, so if you haven't realized, guys, I'll give you guys, here's the shortcut. This is why it's called product of powers. If you are ever multiplying, all right, so if you're ever multiplying, again, that's what it means by product. If you're ever multiplying and you have the same base, take a look, this was r and r, this was a and a, this was k and k. I wasn't multiplying two different things, or two different bases. So if you're ever multiplying and you have the same base, what is the shortcut? I can just go ahead and add those exponents instead of having to expand it. This is exhausting. Imagine if I give you guys like r to the 400th power. That's ridiculous. So the shortcut is you just go ahead and you add the exponents. 2 plus 3 here in the first example gives me 5. In the second example, a to the 4th, 4, and then the a to the 1st, 4 plus 1 gives us 5, a to the 5th power. So I can skip all of that work. Same thing for the third example, k to the 7th. There were 7 k's times k to the 2nd. There was 2 more. Well, 7 plus 2 is going to give us 9. And this is a little awkward because you're multiplying, but you end up adding the exponents, right? So again, it is a little awkward. So let's move on to the next one here, see if we can figure it out. So one more time, product, we are multiplying. I have the same base, 2 and 2. Instead of having to write those 2's all out, I just want to rewrite this. What I would do is I would add 3, the power of 3 and the power of 2. 3 plus 2 gives me 5. This would be 2 to the 5th power. Okay, so there you have it, product of powers. What do we do? If you're ever multiplying and you have the same base, so here it is, product of powers. When multiplying two terms with the same base, it has to have that same base at the bottom, and we do have to multiply. All you're going to do is you're going to have to just add those exponents. So here you see that we're adding the n and the m. Obviously, those would be some kind of numbers, right? So let me give you an actual example. A to the, and I'm going to exaggerate this, a to the 100th times a to the 200th. Nobody wants to sit here and expand that out, a times a times a times a times a 100 times, and then do the same thing with a to the 200th power, a times a 200 times, right? So what I can do, if I can remember this shortcut, this is what we call product of powers. I'm multiplying, I have the same bases, I'm going to just simply add those exponents. The base stays the same, the base does not change, but 100 plus 200 is going to give us 300. All right, so there you have it. That is simplified. That is simplified. That is simplified. All right, let's move on to the next. Couple of examples here. What I would like for you guys to do is I want you guys to pause the video here And then try as many as you can. I know some of these bottom ones are a little awkward, but again, go for it, go for it, go for it, go for it. It does not hurt. It does not hurt to kind of try and give me your best guess. All right, so when you're ready for the solutions, go ahead and hit play. All right, so for this first one, here we have r to the fifth times r to the third. I'm multiplying. I have the same base. Let me just go ahead and add those exponents. So 5 plus 3 is going to give us 8. That is r to the 8th power. You could sit here and do r times r times r times r times r 5 times, and then another r times r times r, 3 r's, right, for a total of 1, 2, 3, 4, 5, 6, 7, 8. But nobody wants to do that. This is why it's important that we know these properties of exponents. These shortcuts, I should say. All right, what about the next one here? Well, I have x, same base, times we're multiplying, so it's product. So how do I add these exponents? I know I should add 6, and then what the heck is over here? Well, if we don't see it, there's going to be a 1. So what is 1 plus 6? That gives us 7. That is x to the 7th power when we go through and simplify. All right, for the third one down here, this is actually still multiplication. This is still multiplication. Whenever you have two parentheses next to each other like that, we are multiplying, right? This is still w to the third times w to the fourth. Same basis. I am multiplying. So what am I going to do with those exponents? We're just going to add them. That gives me w to the seventh. All right. For the fourth one here, we are multiplying, right? There is a bunch of multiplication in between here. X to the fourth times y to the third times x to the second times y to the seventh. So what you want to do is you want to keep your bases, since we are multiplying all the way across. You want to keep your bases with your bases. You basically have two of these problems put together in one. What I mean by that, let's take a look at your x's. Focus on this first part here, x to the fourth. So imagine you just had this, x to the fourth times, and then you had this part over here, x to the second. Let me just focus on that. I'm actually going to cover up the y's for a minute, pretend they were never there. Well, if I know that I have x to the fourth times x to the second, I can just quickly add those exponents and I'll get x to the sixth. That is going to be the first half, the first part of my answer. And guess what we're going to do now? We're going to go back and do the same thing, but this time we're going to do it with the y's. And again, I'll show my work here on the side. Let me pick a different color that kind of stands out. If we ignore the x's for a minute, right, those we want to work with the same basis. We have y to the third times y to the seventh. You could write it out again if you wanted to. Y to the third times y to the seventh. We're multiplying. We have the same basis, y and y. So we can add 3 plus 7, which gives us 10. That's the second part of your answer, y to the 10th. So again, don't feel intimidated, guys. It's just two problems. Think of it as two mini problems in one. This is the answer though that I'm looking for right there. X to the sixth, y to the 10th. I'm actually going to skip down straight down so we can kind of do that bottom one here. Same idea, right? Take a look. We're multiplying. If I cover up those b's so I can just focus on the a's, we have a to the fifth times a to the third. Well, 5 plus 3 is going to give us 8. So that's going to give us a to the 8th power. Now, again, let's focus on the second part of the problem, right? Let's cover up those a's. If you want to rewrite the problem, you're more than welcome to, just like we did above. But here we have b to the second times b to the ninth. Well, we're multiplying product. We have the same base, b and b. So let's go ahead and use that shortcut. We're going to add those exponents. 2 plus 9 gives us 11. b to the 11th power. Now again, these shortcuts, it is going to beat having to go through and expand it. Nobody wants to sit here. So again, this is why I encourage you guys, please make sure you commit these to memory as soon as possible. You don't want to do it the good old fashioned way because it can take very, very long depending on the numbers that I give you. All right, so the last one here that I saved, and again, this one's a little awkward. The 2 and the negative 3, those are your bases, but you got to be careful here. What I'm going to do is I'm going to cover up those x's just like I did on the other one. Let's just focus. Let's pretend those x's were never there. What kind of problem do you have right now? Well, you have 2 times negative 3. What is 2 times negative 3? Well, that is negative 6. So the first part of my answer is actually going to be negative 6. We're not adding those. Those are just nice numbers, what we call integers. We're just going to go ahead and multiply those together. Now let's cover up those numbers, since we've already dealt with them, let's cover up that 2. Right, that coefficient of 2, that -3, also coefficient. And take a look at what we have now. X to the second times x to the 4th. Same base, we're multiplying. Product of power says we're going to add those exponents. We're going to get x to the 6th. So my full answer here is -6x to the 6th power. There we have it, there we have it, there we have it. All right, so a lot of these problems, guys, you can break them down smaller and just focus on bit by bit, piece by piece. All right, now careful, there is a difference when you are multiplying versus when you're dividing. When you're multiplying, you have the same basis, you can go ahead and add those exponents. Here, 4 plus 4 would give us r to the 8th. Be careful when you are adding r to the 4th plus r to the 4th. This is actually 1r to the 4th plus 1r to the 4th, which would give us 2r to the 4th power. So please be careful, please be careful. We're only dealing with multiplication right now. All right, we're only dealing with when you're multiplying and you have the same base. You'll see this later on this semester. All right, the next one, guys, that we have here is called power to a power. Why is it called power to a power? It's because you have an exponent being kicked up to another exponent. So let's see if you guys can spot the pattern here. So this first one here, r to the second, all of that in parentheses to the 3rd power. What does this exponent mean? It means that whatever's on the inside, I have 3 copies of that. What I mean is that I have r to the second times r to the second times r to the second. And if I think back to the last property we talked about, if we're over multiplying, we are multiplying all these 3 r's, and we have the same base, r, and r. I can go through and add those exponents. 2 plus 2 plus 2 gives me 6, r to the 6th power, right? And you could expand it if you wanted to. So let's keep it going. Let's see if you guys can find this pattern. Let's move on to the next one. 8 to the 4th and all of that in parentheses to the 2nd power. So again, what does this mean? We have 2 copies. Whoa. We have 2 copies of what is inside. What I mean by that is we have 8 to the 4th times a to the 4th. Well, I've already learned that if I'm multiplying a and a, same base, and I'm multiplying, I can add 4 and 4, which gives me 8. A to the 8th power. All right, let's try that one more time here. K to the 7th to the 2nd power. Again, that power of 2, it's a power, it's an exponent of a 7 being raised to another power. This is why it's called power to a power. Again, this means we have 2 copies of what's inside. K to the 7th times k to the 7th. We have 2 copies of what was inside. And again, now that we are multiplying 2k's, and we have same basis, k and k, we can add those. 7 plus 7 is going to give us 14, k to the 14th power. All right, here's the secret. If you have not found out the pattern, what is the pattern? Whenever you have an exponent being raised to another exponent, you're simply going to multiply those powers. You're simply just going to go ahead and multiply those powers. So let me erase that. What is 3, the power of 3 times the power of 2? Well, 3 times 2 gives you 6. Over here, we have 4 times 2. What's 4 times 2? That is 8, 8 to the 8th. What is 7? That power of 7 times the power of 2 there, because it's a power to a power. That gives us 14. So if I want to skip this shenanigans in the middle, let's take a look at the last one. 2 to the 3rd power, all of that to the 2nd power. What am I going to do with that 3 and that 2? We're going to go ahead and multiply those together. This would be 2. 3 times 2 gives us 6. 2 to the 6th power. 2 to the 6th power. Right, and that's as far as I want you guys to take it. You could expand it and multiply it, but we'll keep it there. All right, so again, this is what we call power to a power, guys. If you ever have an exponent being raised to another, you're simply going to multiply those. Let me give you guys another exaggerated example here. Nobody wants to sit here and expand something like, let's say we have x to the 2nd, all of that to the 100. Nobody wants to sit here and do x to the 2nd, write 100 copies of that, and then go through and multiply it. So the shortcut is whenever you have a power, oh, sorry, I should circle the 2 first, but whenever you have a power being raised to another power, we're simply going to multiply those. So what would this be? X to the 2nd, all of that to the 100. 2 times 100 gives us 200. That would be x to the 200th power. All right, just like the last ones, guys, Take a minute. And again, I know some of these bottom ones are a little awkward. No worries, no worries. Do the best you can. And when you're ready to see the solutions, go ahead and hit play. All right, so for these, we are focusing on power to a power. I see that I have r to the 5th to the 3rd power. I have a power being raised to a power, so 5 times 3 is going to give us 15. This is r to the 15th power. Very similar to the next one here. 3x to the 3rd power, all of that to the 6th power. Power being raised to a power. We multiply those. 3 times 6 gives us 18. All right. Now, this next one is a little awkward. So what I'm going to do is I'm actually going to expand it out so you guys can see what is actually happening here, because they can get a little tricky. So 2x to the 3rd power. This 3 means that we have 3 copies of what's inside. So let me actually expand this out, and then I'll show you guys kind of the other way to approach it. But you would write 2x times 2x times 2x. Well, if I go through and actually multiply that out, what is 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. And if I do the same thing with the x's, what's x times another x? That's going to give me x to the 3rd. There's 3 x's. So you could go through and expand it out like that and go through and multiply. Or if you want to think of it this way, the 2 here has a power of 1, and so does the x. You could actually, I hate to use the word distribute, but you're multiplying, and don't use that word, I take it back. You're multiplying here 3 times the power of 1. Well, what's 3 times 1? Take a look, we have x to the 3rd power. And if you multiply that over here, 3 times the 1 on the 2, that would give you 2, and then 1 times 3 gives you 3. If you actually multiply that out, that's 2 times 2 times 2, 3 times, which is going to give you 8. So it's up to you how you want to look at it. So a lot of people prefer to actually expand it out when it comes to these and then go through and multiply. But it's completely up to you how you want to look at it. So if I actually use that same approach here for the next one, I'm going to use that other shortcut where I put the power of, well, this one already has an exponent. The 3, however, we're going to go ahead and include that 1. If I use that other shortcut, 7 times 2, that right there would give us 14. I know I'm going to have n to the 14th power. And if I do 2 times the 1 here, I know I'm going to have 3 to the 2nd power. But we can even do better than 3 to the 2nd power. What's 3 to the 2nd? That means 3 times 3, which is 9. That would turn into 9n to the 14th. If you didn't like that, what could you do? What could you do? What could you do? You could still go ahead and, whoops, we could still go ahead and rewrite this. This says 2, the power of 2 here says that you have 2 copies of what's inside. So this entire thing, 3n to the 7th times another 3n to the 7th. And just like we did before, what's 3 times 3? Well, that gives us 9. What's n to the 7th times n to the 7th? 7 plus 7 gives us 14. Completely up to you which way you want to approach it. All right, it's up to you. It's up to you. All right, for this next one, what I'm going to do here is I'm simply just going to multiply. Since I have a power to a power, I'm actually going to cover up the denominator. So imagine this wasn't there. So take a minute, take a minute, take a minute, take a minute. Pretend that was never there. Doesn't this look like the very first one we did up here? R to the 5th times R to the 3rd. Sorry, R to the 5th to the 3rd power. So what's R to the 4th to the 3rd power? Whenever you have a power to a power, we still multiply. That's going to give us R to the 12th. And then if we do the same thing with the bottom, so imagine now the numerator's gone, and we have this. We have W to the 5th power and that to the 3rd power. What's 3 times 5? That would give us 15. This would be W to the 15th power. W to the 15th power. All right. Well, no. Erase. Why won't it not let me erase? There it goes. All right. Now for this last one here, I'll use a different approach for this one. You could go through and add ones, but what I'll do is I'll make 2 copies of it. This video is getting a little long, so the power of 2 means you have 2 copies of everything that's inside. So we have 4b over b to the 2nd times another 4b to the 2nd. and then b to the second power. Well, if we remember how to multiply fractions, we simply multiply across the top and across the denominator. 4 times 4 gives us 16. B to the second times b to the second, with same basis, we're multiplying, we're going to add those exponents, we get b to the fourth power. This would turn into 16 over b to the fourth power. The other way you could have done it is, again, just by kind of focusing here, piece by piece. What is 4 to the second power? 4 to the power of 2. That means you have 4 times 4, which gives us 16. And then if you looked at the bottom here, just focused on the bottom, we have 2 times 2, which gives us what? 4, b to the fourth power. Again, it's up to you. It's up to you. It's up to you how you want to approach it. All right, guys. So there you have it. Product of powers and power to power, the two shortcuts that we learned today. What I want you guys to do is go through and practice here. All right. When you're done, make sure you guys are doing this on a separate piece of paper. Again, not on your notes, separate piece of paper. You will turn it in. Once you finish, check your answers with the sub. They do have the answer key. If everything's perfect, go ahead and submit it. Whatever you do not finish becomes homework. All right, guys, take care. Have a wonderful day.